So a very good day to Dr. Mansour and all my fellow classmates. So today my name is Remly Martin Benjamin and I like to present about my project entitled Electromagnetic Thickness Gauge, which is under the PLT, and this is mainly regarding corrosion evaluation. So starting off, I'll be presenting about the introduction, the working principle as well as the measurement ways of the ETG, followed by the current status and technological advancement, field example of ETG, conclusion, and the references that I've used all along the way. Alright, so beginning will be my introduction, whereby it comprises of the objectives of study. So as for this part, it is to investigate the corrosion and pitting in the downhole pipe, followed by to distinguish between the internal and external damage to the pipe. So as we can see in the figure, where we can spot the internal damage as well as the external corrosion as well. So basically this is to identify a specific place and location of the damage caused by corrosion. And next will be to determine the total metal diameters, thickness, defect imaging inside a single and multiple casings. So this will be the objective of the study. Next, I'll go to the fundamentals of our study and the advancement all along the way. So as for the fundamentals, this is some of the science basic, whereby pipe corrosion is a natural phenomenon in the harsh environment of oil and gas production, wells costing billions of dollars each year. So, monitoring such corrosion allows for timely mitigation to prevent leaks, environmental damage, or catastrophic failures. So, basically, corrosion is mainly caused by some of the gases such as oxygen or not reservoir rich in H2S or CO2, because all these gases either have a high content of water or not they comes in high acidity. So these are some of the causes that can lead to corrosion. So for the advancement, there are various kinds, whereby firstly they have discovered mechanical calipers, whereby the con of it is it provides only the internal diameter of the inspected tubular. So basically it doesn't measure other than that, it only measures the internal diameter of the tubing, and then followed by the ultrasonic tool. So as for this, it measures both the ID and also the wall thickness. But however, for the disadvantage is that it is only been used in a single casing string configuration. So it can't be used in multiple casings as well. So, and finally, they have discovered the latest one, which is the electromagnetic tool, whereby we can say it's a conventional one being used in the industry these days. So it is to evaluate the corrosion in any environment, including gas-filled tubular, in single string and also multi-string configurations. So this is the advancement so far throughout the years. Next will be the working principles of the ETG, the electromagnetic thickness gauge. So as we can see here, there are few different what the components that is in the ETG, and the first one will be the mandrel mounted coils. So mandrel mounted coil is basically an average metal thickness, whereby it is measured using this mandrel mounted, and also it is to remove ghosts. So basically ghost is the extra response caused when the transmitter passes in front of a defect. Alright, so followed by the 18 pad sensors. So the 18 pad sensors, as we can see, is at the top part of the ETG. So it is actually in a form of a radial arm cage. So in this radial arm cage, that is where these sensors are located. So it actually measures the high resolution image of the metal thickness using the low frequency transmitters. And then it's the high frequency signals. So basically, these high frequency signals, they they obtain all kinds of image defect image of internally of the inner walls. And then finally is a transmitter and two closely spaced receiver coils. So basically they measure the inner diameter of the tubular and also the casing impedance. All right, next will be the measurement interpretation. So this will be one of like the log interpretation. However, this is in terms of the casing interpretation of the diameter and of the thickness of the casing itself. So as we can see at our track number 6 in the 2D thickness image, it is shown that it is clearly shown that there is a metal loss in terms of the red colorings below the XY15 feet. And for the discriminated log of the 2D, we can actually spot that there are brown color. So basically those brown color indicates the perforation zones. So that this observation indicates that there is a loss on the outside wall of the casing. So basically, this is some of the observation that can be obtained from our measurement based on this log. All right. So next will be our technological advancement and our current status. So firstly, there were once a flux linkage tool which was used to measure the magnetic flux anomalies, and it is well suited to detect pitching, holes, and also corrosion patches. However, the disadvantage is that they are not designed for large scale corrosion or multiple casing string. So next, they have moved on to the remote field eddy current, which is an RFEC tool. So it is to measure the response of the transmitted electromagnetic field. And this tool, in an advantage part, we can see that it is well suited for large scale corrosion, vertical splits, and also large oil, as well as operation in multiple casing string. So this is one of the latest technology. However, it's not very latest yet because it have been found few years back, according to some of the articles that went through earlier. So, however, nowadays the latest trend that is emerging technology that is coming out right now is the RFEC electromagnetic, as well as the multi-tubular electromagnetic corrosion inspection tool. So these two tools seems to be a very latest tool because it enables the monitoring of well casing integrity, as well as it provides a high resolution imaging. So they have this kind of similarities between both of it. And next is the field examples. So there are few fields that have conducted this kind of interpretation is measuring, whereby they use ETG to measure the corrosion. Therefore, some of it is San Juan Basin in New Mexico, Uinta Basin in Western Colorado, Joffre Field in Alberta, Canada, and also Kampong Baru Field. Whereby Kampong Baru Field, in detail, they have mentioned that there was corrosion at some of the perforation zone, and this is caused by the H2S because it is a well that produced natural gas together with the composition of H2S. So therefore, corrosion was happening in this field as well. So that's all as an overall of the study of. So therefore, the conclusion I could summarize is, in summary, electromagnetic thickness gauge are indispensable tool in the oil and gas industry, enabling reliable and efficient monitoring of metal structures. Their non-destructive nature, portability, and ability to operate in challenging conditions make them essential for maintaining safety, minimizing downtime, and also maximizing the lifespan of critical assets. So that's all. And these are some of the references that I've conducted in order to complete this study on this ETG. And that's all from me. Thank you.